Hello everyone. In this hands-on session, we are going to create our very first Kubernetes workload, the pod. We will start with the declarative method by writing a YAML file inside VS Code. Then we will use the imperative command to create the same pod. Finally, we will explore how to debug and troubleshoot a pod using kubectl commands. Let's start by creating a pod using the declarative method. Here is the YAML file, and I will explain each line step by step. The API version. V1 sets the Kubernetes API version used to create the pod, which is required for all core resources like pods. The kind. Pod specifies that the object we are creating is a pod. Under metadata, we provide identifying information for the pod, including its unique name, mypod, and labels. The labels, such as app nginx, help organize and select the pod for management and operations. The spec section defines the pod's desired state and its contents. Within spec, the containers list specifies the containers that will run inside the pod. Each container is given a name, here nginx container, and an image, which in this example is nginx, latest. The ports section under the container specifies which ports are exposed, and container port 80 makes port 80 available for HTTP traffic inside the pod. This YAML defines a simple pod that runs a single nginx container, ready to serve traffic. Now let's create our first pod. To help with your preparation, I've organized a comprehensive README document for each Kubernetes object, which includes all the commands used in this hands-on session. This will serve as a valuable reference as you continue your studies. Here, for example, we have the command to use to apply our YAML file. Let's copy this command. kubectl apply.fpod YAML. To check if the pod is created, we use the command kubectl get pods. Our pod is well created, and it is running and ready. Great, now let's create the same pod using the imperative method. I will explain each part of the command. kubectl run mypod creates a pod named mypod2, -- image equals nginx. Latest tells Kubernetes to use the nginx, latest container image, -- port equals 80 exposes port 80 on the container, which is needed for HTTP traffic. Let's execute it and create our second pod. Again, to check if the pod is created, we use the command kubectl get pods. Good. Our second pod is created, and it's running. Now for debugging and troubleshooting, we use the following commands. kubectl get pods -n default, n means namespace. This command lists all pods in the default namespace, shows the name, status, number of restarts, and age of each pod. Next, to get more information about the pod, we use the command kubectl describe pod mypod. This command shows detailed information about the pod mypod, labels, node placement, container details, and events such as scheduling or image pull failures. In the describe output, we are looking at the pod mypod, which is running in the default namespace. We see that the pod is scheduled on the Minikube node, and it has the label app nginx. Labels are important because they are used later by services or deployments to select this pod. The pod is in the running status, with an internal cluster, IP 10.244.0.16. This IP is only accessible inside the cluster. Inside the pod, there is one container, also called mypod, which is using the nginx, latest image. The container exposes port 80 over TCP. Its state is running, it started successfully, and it has restart count equals 0, which means it has not crashed or restarted since it was created. The conditions section shows us that the pod is initialized, ready, and scheduled. All are marked as true, which confirms the pod is healthy. At the bottom, the events section is very important for troubleshooting in the exam. Here we can see the lifecycle. The scheduler assigned the pod to the Minikube node. The image nginx, latest, was pulled successfully. The container was created and started without issues. So, the key takeaway is, the pod is running and healthy, with no errors in events. Now to see the logs of the pod, we use the command kubectl logs mypod. This command displays the logs generated by the container inside the pod, useful for debugging application-level errors. When we run kubectl logs mypod, we see the logs from the nginx container inside the pod. At the beginning, the entry point script runs. This script checks the Docker entry point, D directory for configuration scripts. Then, the logs confirm. Configuration complete, ready for startup. This means Nginx has finished its setup and is now ready to serve requests. After that, we see Nginx starting with the epoll event method. This is just an internal optimization for handling multiple connections efficiently. We also see the version, Nginx version 1.29.1, the build info, and the Linux kernel version running in the container. Finally, the logs show worker processes starting up. These are the processes that will handle incoming HTTP requests. These logs confirm that Nginx started successfully with no errors. If there were issues, you would usually see errors or crash messages here, like failed to start, connection refused, or file not found. So, kubectl logs is another essential troubleshooting tool to quickly verify if your container is healthy. Now to interact with the pod, we use the command kubectl exec-it mypod-bin/bash. This command opens an interactive shell session inside the container running in the pod, allowing troubleshooting from inside the environment. Finally, to delete the created pod, we use the command kubectl delete pod mypod. This removes the pod mypod from the cluster, useful for cleaning up after testing. In summary, in this hands-on session, we created our very first Kubernetes workload, the pod. We built it with the declarative method using a YAML file, then created the same pod using the imperative method. I strongly recommend practicing and practicing again this commands directly in your terminal. Aim to type and execute it swiftly, so you can save precious time during the exam. I hope you like it and see you in the next lecture.